So I've got x equals 2 sine t, y equals 2 cos t. How about when t equals pi halves? All right, well, x of pi halves equals 2 sine of pi halves, which I know is 2, and y of pi halves equals 2 cos of pi halves, which is 0, because cosine of pi half. Now, what does that imply? It means that when this thing gets carved out, let me redraw it over here. When this thing gets carved out, it means I have to take into account direction. All right? I remember when t was 0, I get sine was 2. And then what happens is it carves out my circle. Ooh, that's a badly drawn circle. Sorry, guys. It starts here, and it carves it out in a clockwise direction. Now, in class, we're going to play around with what happens if we want this thing to start at over here. What if I want to start at 0, -2? Well, what would I do? Well, we'll think about that. What if I wanted to carve out in the counterclockwise direction? Well, we're going to play with that as well. All right? But that doesn't take a whole lot. Now, I do want to play with, how about if I wanted an ellipse? Can you intuitively figure out what would happen if I wanted an ellipse? All right? Let's say that I wanted this ellipse, and then we'll play with it on our calculators. I want an ellipse. Ooh, that's bad. Sorry, you guys. Let's say that goes through 4, 0, all right, and 0, 2, and 0, -2, and -4, 0. All right? Now, again, let's not worry about where it starts. Let's just worry about the end result. What do you think intuitively, based on the fact that this thing makes a circle of radius 2? Well, I'm thinking, since I want my x to be longer, I'm going to make my x of t equal to, I'm going to make it 4, let's make it 4 cos t. I'm going to change it up, and we'll see if that, notice how over here my x was sine t. And I'm going to let's see, y of t equal, what do you think, 2 sine t? All right, now I'm going to stumble back over here, and let's see what happens. If I go up here, now I want this to be a little easier. If I go 4, and then cos, and then 2, let's see, I'm going to do 2 in sine, and then I'm going to graph it. Let's graph. See what happens. Well, looky here. That's pretty cool. Look at that. Now, did you see where it started? If you didn't, it's no big deal. Watch. I know that x of 0 equals 4. So I know it started right there. I know that y of 0 equals 0. It starts at the point 4, 0. And then I could regraph it if I wanted to see which direction it carved out. Or I could test it again. So let's see. If I go zoom, watch this. I'm going to cheat and go zoom square, and it's going to give it to me again. So there. Oh, it went counterclockwise. It carved out counterclockwise. Now, it started right there. That was t equals 0. So the limits that we put on t are very, very important. Now, think about this. What if I only wanted to do the top half? Just the top half of this ellipse. What do you think? Remember what happened when our window was all crazy with the one function back here? When our window, we only got half. Remember when we started out, t was between 0 and 2 pi. Well, what do you think is going to happen here? If I want to carve out just the top half of this ellipse, what do you think? Well, I'm thinking we'll just, instead of going the full 2 pi, let's just go from 0 to pi. Whoops, not 0 to e. That would just be silly. Clear 0 to pi. I did it again. Wow. Sorry. 0 to pi. There we go. Now, let's see. Graph it. Top half. Isn't that cool? That's really fun. Okay. Now, we're going to play with this a bunch more in class. I do want to show you how to convert, just real quick, a couple things. I want to be able to show you how to convert regular old functions, which I already did. Given any function, f of x equals, I don't know, 5x over the square root of 2x squared plus 1. being able to convert a function to parametrics is really simple. I just let x of t equal t. I let y of t, equal 5t over the square root of 2t squared plus 1. You've seen this before. Let's say that I have x as a function of y, right? So I got x equals the square root of y squared plus 3y plus 1. All I do is I let y equal t, and then I let x equal, I don't know why I put parentheses there, that was crazy, x equal t squared plus 3t plus 1. All right? And this will graph. It'll graph it. Let's graph that. Let's see what that thing looks like, okay? So let's see. I got to go back. I'm going to shrink this thing down and go back to my calculator. Let's have a look-see, because to be honest with you, I mean, I can guess at what this thing looks like. It's probably like half of a circle, but let's see, because it's the square root of something squared, right? So let's clear it out. I'm going to let x of t equal the square root of t squared plus 3t plus 1 plus 1. Did that not put parentheses in there? It didn't, did it? So I'm going to have to insert some parentheses, otherwise all hell's going to break loose. Oh no, it got them in there. Perfect. So according to this, it got them in there. We'll see. If I don't like the way it looks, we'll change it. And then we'll just stick in t, and we're going to go, what was our window? It was 0 to pi. Let's go negative 10 to 10, even though we may not get that. Oh, one other thing I want to comment on. Negative 10 to 10. Look at this t step. This is the standard step. If this t step gets too big, I'll show you what happens. Ooh, but look at this first. This is kind of cool. Check it out. Look at my graph down here. It's kind of nice how it graphs it already. It appears that what we have over there is we have something that looks like this. Something like that. Well, clearly isn't a function. It doesn't pass the vertical line test, right? Now, let me show you what happens if I mess with this t step. But let's see, it would be better if we did it with a circle. So let's go back to y equals, and I'll clear this guy out. Let's do our circle real quick. Sorry about this, you guys. Let's go 4 cos t. I'm going to keep it simple, and we'll make it 4 sine t, 4 sine t. And notice over here, let's see, 4 sine t, 4 cos t, I'm good there, 4 sine t, and I don't know, let's see, oh, I've got my t here. I'm going to hit enter, and that should give me my circle. Let's see what happens. There's my circle right there. Now, watch. If I mess with this t step accidentally, this is the default setting, but if for some reason, let's say that, because it can get screwed up, it can get really janky, I'm going to make it 1. Did you see what happened to my circle there? If I go like this, what happens is this gets really, really crazy. If I set my window to, let's go to zoom standard, which is 6. Okay, now, again, I'm going to go zoom box on it. Sorry about that. Now, I'm from 0 to 6.2, but watch this. If I go from 0 to 6.28, and I'm going to make my t-step 1, see what happens? Look over here. See, and the reason is that what the calculator is doing is it's starting t at 0, and then it's going when t equals 1. That's where it takes the next step. So that's why they have it at 0.13. That seems to be sort of a Faustian deal with the devil to be able to make it do what they want it to do. All right, now watch what happens here. It goes back to looking more circular. All right, now if I'm like, well, I want total detail. If I go 0.01, watch what happens. The calculator takes forever. You'll see this. Well, let's go zoom box. So zoom square 5. Watch what happens here. See how it's taking forever to carve this thing out? It's because the calculator is having to compute every 0.01. So it takes a really long time. Now, you do get better definition, but it takes a really long time. In fact, in this case, because the definition is so fine and the pixelation on the screen can't pick up all that detail, you end up looking more jagged than you want it to. So the moral of the story is leave it at its defaults. And if you get something crazy that doesn't look right, go back and check your default. So I'm just going to set it to 0.13. I'm going to hit enter. And then let's hit zoom box again and watch how much, or zoom square again, and watch how fast it carves it out. Boom, boom, just like you want it to. Okay? All right, right on. Now, let's get back over here. The hard part is let's say that I do this. Let's say that I let x of t equal 2t plus 1, and I let y of t equal the square root of t squared minus 3. If I want to convert this into a straight up function f of x, then what I have to do is I have to solve for t over here. So this is true if and only if t is equal to x minus 1 over 2. And then I simply plug this t value into here. And here's what I get. I get f of x, which is, think of that as just being y of x, it's the same thing, is the square root of x minus 1 over 2 squared minus 3. All right? This is what this function looks like. All right? Now, sometimes you're not going to be able to solve and make it f of x. You may have to turn it into an f of y if this guy isn't a function of x. In this case, it happens to be a function of x. And then I can graph it, and I can look at it and do all of those good things. Again, this should be review. There shouldn't be anything new here. So check it out, play with it, enjoy. I'll see you in class tomorrow, and we'll actually have a little bit more fun with it too. I think you'll enjoy it. All right, thanks for your time and attention.